For this lesson, we're going to look at what a function is, and then also how to identify a function if we're given a list of values, a table, a mapping diagram, and a graph. So first we have a relation, and that is just a set, which is a list of ordered pairs. So a list of points on a graph. Like in number 2 here, this is a relations. It's just a bunch of ordered pairs together. And those are always going to be a relation. A special type of relation, so a special list, is called a function, and this is when each x value, so that's the first number, has exactly one y number. Exactly one y value. And as we look at examples, we'll see what that means. The domain is the x values. So if we look at all the x values together, that's called the domain. And then the range would be the y values of a relation. So in a list of ordered pairs, all the y values would be the range. Vertical line test, this is what we can use on a graph to test if it's a function or not. And it really is just that. You draw a vertical line through a graph, and it can only go through the graph at one point at a time. So it's a test for functions. And it can only goes through one point. If it goes through any more than one point, then the graph fails a vertical line test, and then it's not a function. And just a quick review of linear and nonlinear. Remember, linear is a graph that makes a straight line, a single straight line. Doesn't change directions at all, single straight line. And then a nonlinear is a graph that does not form a straight line. So let's look at some examples. It says determine whether each relation is a function, and if not, explains whether it's a function or not a function. If we say that it's not, we have to show or tell why it's not. So the first thing you want to do is you want to look at the x values. X is 2, 4, 6, 8. So in this case, all of them are different. If all of the x values are different, we have to assume that based on the information we are given, it is a function. 2 only matches up with 5. 4 only matches up with 6. 6 goes to 5. 8 goes to 6. On number 2, we have a 5, a 4, a 3, a 2. Again, all the x numbers are different, so we have to assume based on what we know, this is going to be a function. When we get down to number 3, this is where we start seeing kind of what this really means to be a function. This one says that 1, I have a 1 and a 1, so I've got 1 on here twice. This one tells me that the 1 has to go to 5. So if I see another 1 in my list, it better also go to 5. And here's another 1, but look, it also goes to 5. So that part's okay. 1 goes to 5, 1 has to go to 5. If I add another 1 to this list, it would have to go to 5. But then when I get to the 2, this tells me that 2 must go to 7. But then I see another 2, and now it goes to not 7. So this makes it not a function. So these here make this not a function. And then we have to explain why. We can say 2 can't map to 7 and 8. Okay, and well, let's check number 4. So we're gonna check the x numbers. 3, 5, 4, 9, 5. So I have, this has an x or a domain of 5. This has an x value of 5. So because those x values repeat, those are the ones I'm going to look at. And this first one tells me that if I have an x of 5, I better go to 7. So if I add another 5 in this list, it has to go to 7. But then I look at the second one and I see that it goes to 4. So that makes it not a function. And that is because 5 can't map to 7 and 4. So whatever, you see the first one, this is our first 5. It kind of sets the rule. The rule is if I put in a 5 for x, I better get out a 7 for y. So anything else that has a 5 better go to 7. And then once that rule is broken, it's not a function. Looking at the next one, this is a mapping diagram. And this one's kind of easy because you just got to follow the arrows. So this first one tells me that this -3 maps to 3. The -2 maps to -6. -1 maps to 0. 0 maps to 15. 1 maps to -1. So none of the x values repeat. It's always x first and then y. So none of the x values repeat. So then it must be a function. Because remember, if it's when the x values repeat that we need to check something. So when I check number 6, -3 only goes to the -6. -2 only goes to the -1. -1 only goes to 0. 0 only goes to 3. Here's where it gets different. This one says that it's got 2 arrows. It says that 1 goes to 0, but it also says that 1 goes to 15. And 1 can't go to 2 different places. So this is not a function. And that is because 1 can't map to both 3 and 15. It could go to 3 a bunch of times, but it can't go to 2 different numbers. And if we look back at number 1 here, notice that it's okay. We had a 5 and another 5 for y. It's okay that the y's repeat. It's just when the x's repeat that it's a problem. If the x's repeat, like number 3, 2 and 2, it has to have the same y. It doesn't matter if the y's repeat. Then we're going to look at using a graph and using that vertical line test. So the vertical line test tells me I'm going to draw a vertical line anywhere through the graph, and it should only go through 1 point. So on number 7, if I draw a vertical line right here, for example, it went through my graph here and here. More than 1 point. So this would be not a function. And because I drew the line and I kind of circled where, that's kind of me telling why already. You can write it in words if you want to, but number 8, if I draw a vertical line here, it's only going through my graph once. So that's okay. And anywhere I draw, so I should be able to draw a vertical line anywhere I want. And every time it's only going through 1 point. So this is going to be a function because no matter where I choose to draw that vertical line, it's only going through 1 point. Number 9, we had to remember a little bit about inequalities. If it was an open circle, that's when it was a less than or a greater than. And this means that that value at that circle is not included. Whereas if it's a filled in circle, that meant it had the less than or equal to, or could be greater than or equal to, and it is included. So if I look at this circle here, and this is at -2, because it's a filled in circle, that is included. So -2 is included in this part here. But this one down here has an open circle. So if I draw my vertical line here, it looks like it's going through 2 points, but it's actually only going through 1. It's going through this one here that's filled in because it's included, but this one is open down here. So this one's technically not included. So really that only goes through 1 point, even though it looks like 2. So this one would be a function. Because the same thing happens here. If I were to draw a vertical line here, it looks like it goes through 2 points, but because this top one is not included, it's open, that doesn't count as a point. So that does not count as a second point. What's a little bit different, though, is in number 10. In number 10, these overlap a little bit here. So if I were to draw my vertical line through here, it's going to go through here and here at 2 different points. This one is not a function. So I should be able to draw that vertical line anywhere in the graph. If I had drawn it here, that's only 1 point. Or here, that's only 1 point. Here is technically 0 points because these are both open. So even if it only fails at one place, if it fails at any one place, the whole thing's not a function. It has to pass that vertical line test anywhere. And then the last one, sketch a linear function. So I could do this so many different ways. I'm just going to draw any straight line with the exception of one. So I'm going to draw one like this. The only straight line that I cannot draw because it says function is a vertical line. So I could not draw this line on a graph because a vertical line will not pass the vertical line test. Every other straight line is going to be a function except for this one. And then it says sketch a nonlinear. So nonlinear means it is not straight. So I can draw any kind of graph that's not straight as long as it would pass the vertical line test. So I could draw one like this. This is called a parabola, the U-shaped graph. That would pass the vertical line test. So that would be an example of a nonlinear, because it's not straight, but it is a function. And then I want to go over one more thing. If we go back up to, let's look at number 5. We talked about domain and range, but we didn't really do an example of that. So let's look at number 5, an example of domain. If it said list the domain, I would simply list all these x numbers. So I'd say -3, -2, -1, 0, and 1. I'm just listing all these x values. And then if I want to list the range, I'm just going to list all the y values. So the range would be -6, -1, 0, 3, and 15. So I'm just listing out only the x for the domain and only the y for the range, and just making a list with commas. And then we're going to do one other thing, one other little definition here to remind ourselves of what a function is. So here's a good way to think about it. If an x value repeats, it must have the same y value. So if the x values don't repeat, it's automatically a function. If the x values do repeat, make sure it also has the same y value. If it doesn't, then that's what makes it not a function.